Today, social robots are no longer just our companions. They are increasingly designed as persuasive agents which aim to help people live healthier lives. For example, a robot might give health-related suggestions, such as encouraging people to exercise more or eat healthier. However, to actually change users' health behaviors, simply giving suggestions is perhaps not enough. Hi everyone, my name is Jiaxing. I'm a fourth-year PhD candidate at Eindhoven University of Technology. Today, I'm excited to present our work, Designing Persuasive Social Robots for Health Behavior Change, a systematic review of behavior change strategies and evaluation methods. Our work aims to answer two key research questions. First, how are social robots being designed to encourage health behavior change? And second, how have behavior change outcomes been evaluated in existing empirical studies? And due to time constraints, today I will mainly focus on the first question. To answer these questions, we conducted a systematic review of empirical studies in HRI. Our inclusion criteria was that the study had to design a social robot aimed at influencing health-related behaviors and include a human-centered evaluation of behavior change outcomes. We developed a set of keywords that included terms related to robots and terms related to persuasion, health behavior change, and specific health behaviors. Using these search strings, we searched throughout 3 databases and also carried out a manual search. And eventually, we ended up with 39 papers that met our criteria. For the included papers, we conducted a thematic analysis using a mixed coding approach. On the one hand, we used established behavior change techniques from health psychology and persuasive system design model as provisional guides for the coding process. At the same time, we used inductive coding to identify the unique patterns specific to the HRI context. We identified 4 main strategy themes, including coaching strategies, social influence strategies, counseling strategies, and persuasion-enhancing strategies. The first theme and the most prevalent one is coaching strategies. This refers to designing social robots to provide action-level support, helping people adopt or maintain certain behaviors. Within this category, 38% of papers included providing suggestions, where robots offer direct recommendations for a healthy action. Beyond that, 49% of studies reported providing instructions, where robots give step-by-step guidance to help users perform certain behaviors. About 31% of studies included explaining health consequences, where robots provided information on the benefits or the risks of certain behaviors. 59% of studies involved providing feedback. Here, robots deliver different types of feedback on user performance, such as descriptive, corrective, positive, or negative motivational feedback. 33% of studies mentioned behavior modeling, where robots physically demonstrated a behavior for users to follow. 5% of studies mentioned providing interactive rewards, where robots rewarded users for performing a desired behavior through interactive ways, such as using lighting effects, singing, or dancing. About 13% of studies mentioned goal-setting strategies, where robots encourage users to set concrete goals in the future. 5% of studies mentioned enabling self-monitoring, where robots prompt users to record their behaviors or provide a digital tool for them to track their behaviors. Finally, 8% of studies mentioned gamifying health activities. For example, one study introduced an exercise task where the robots transformed users' physical movements into musical compositions, making the activity more playful and engaging. The second theme is social influence strategies, where robots are designed to influence users' behaviors by leveraging social roles, social norms, or group dynamics. Within this category, 15% of studies involved shaping users' authority, for example, having robots refer to scientific evidence. In addition, 8% of studies used social conformity, where robots motivates users by emphasizing that a behavior is common, for example by saying that everyone is doing it. About 8% of studies reported leveraging social reciprocity, where robots frame behavior change as part of a mutual exchange. For example, in one study, the robot first asked users to help it with a task and then offered health advice in return. In addition, 5% of studies mentioned cueing social rituals, for instance, using a cheers ratio to encourage users to drink enough water. About 5% of studies mentioned mediating social learning, where robots enable users to observe and learn from others' health behaviors, for example, by sharing information or facilitating group activities. 5% of studies focused on mediating social support, where robots are designed to connect users with other people to support their health behaviors. One study described a strategy of enabling social comparison. In this case, the robot exercised together with the user, but was designed to perform better than the user, thereby triggering a sense of comparison. Another study used enabling cooperation, where the robot and the user work together towards a shared goal. For example, one study introduced a hand clapping exercise that required coordinated movements between the user and the robots to complete the task. The third theme is counseling strategies. Here, robots help users to build internal motivations for behavior change, mainly through dialogue. There are 4 strategies in this category, including prompting verbalization of pros and cons, prompting reflection on past success, prompting imagination of future outcomes, and problem solving. The final theme we identified is persuasion-enhancing strategies. These strategies do not directly persuade on their own, but are often used alongside other strategies to increase their effectiveness. The first is enhancing embodied presence, where robots use multimodal social cues such as eye contact, gestures, and proximity to appear more socially present. The second is personalization, where robots tailor their strategies to users' specific characteristics such as behavioral history, motivational states, or personal preferences. Third is stimulating social bonding. We found that in the persuasion context, robots are often designed with relational behaviors to create a sense of connection with users, for example, by showing empathy or signaling similarity and common ground. Taken together, these strategies highlight the unique affordance of social robots as health behavior interventions, and we hope this framework provides useful design heuristics for future researchers and designers. In terms of evaluation method, we reviewed aspects such as target behavioral domains, intervention duration, study settings, study designs, participant characteristics, and outcome measures. For more details, please refer to our paper. Here are the links to our paper and my LinkedIn. Thank you for your attention. I will be happy to take questions.